all for taking time this afternoon to join this session. Let's get started. Competing business landscape in recent years have caused many organizations to consider migrating their mission control SAP workloads to AWS. SAP workloads usually, especially for the large organizations, are very complex due to their integration, performance, and availability requirements. Hi, my name is Vimal Jain. I'm an SAP consultant at AWS. I help my customer design, build, and migrate SAP workloads to AWS. Today in this session, I'm accompanied by my fellow speaker, Mark Wagner. He's the head of digital infrastructure services at Siemens Smart Infrastructure. Today in this session, you will be hearing from Siemens their perspective on the drivers to migration to cloud, key strategies, and how migration to AWS help them achieve efficiencies for their SAP workloads. So here's our agenda today. We'll have Mark start with give you a brief overview of Siemens Smart Infrastructure and their key strategic priorities. Then he will talk about the key drivers, strategies, and their overall process to migrate their SAP workloads to AWS. Then we'll talk about our process to design the architecture for SAP workloads for Siemens and the migration approach we used. Then we'll move on to look at the key business and technical benefits which Siemens achieved out of migration of their SAP workloads to AWS, and how having SAP on AWS as a foundation helped them improve their machine learning-based analytics platform on AWS with SAP data. Before we wrap up, we'll look at recent innovation announcement from SAP on AWS, and then we'll have some time for Q&A for you to have an opportunity to ask questions to me and my fellow speaker, Mark. I'll hand over now to Mark to introduce himself further and take you through the journey for Siemens SAP on AWS migration. Thank you.
Thank you, Vima. So, welcome everybody also from my side. I cannot really see you guys due to the light, but I hope you can see me. So, for the ones who don't know Siemens, just a brief overview about Siemens Smart Infrastructure. Siemens Smart Infrastructure is one part of Siemens. So we have different businesses like digital industries, mobility, and smart infrastructure. We're running around about currently 19 billion revenue and have about 72,000 employees, so quite a number. What we're doing from a business type of view is we're trying to help our customers to accelerate their own digital transformation. I think digital transformation you hear every day. Meanwhile, smart infrastructure is more in an old-fashioned business in regards of buildings. What we try to do is to make building speaks. Building per se are not so smart, right? But we try to gather data from the building and therefore try to combine the real world and the digital world. So, for example, what you can think of, we have so-called building management stations. We collect a lot of data from the building, analyze the data, and giving customers insights where to get more sustainable, where to save energy, how to improve the CO2 emission of a building. And it's not limited to the building, but also we provide electricity to the building. So that's a little bit our portfolio. And with combining the real and the digital world, we try really to give some new insights to our customers. Our four strategic priorities within Siemens is customer impact. Like AWS, we try to have a customer-first perspective. We try to anticipate the customer needs before they do, also giving them insights on their installed base. Technology with purpose, not sure if you know, but Siemens is a pretty old company, more than 170 years. Research and development and innovation has always been to our heart. So that's why also the SAP move to the cloud has a certain share in this technology with purpose focus. And the last two topics, empower people, growth mindset. we try really to drive progress not only internal but also for and with our customers, and really looking forward rather than looking what was in the past, but really trying to anticipate future changes. So how does it now match to our SAP journey? So first, what is our SAP landscape at Siemens and Siemens Smart Infrastructure? We have a lot of SAP systems. Some of them are managed by our central IT colleagues, some are managed by the businesses itself. In our case, we had 6 SAP system lines or system landscapes, which encompass normally all the modules you can think of, starting financial controlling, material management, production planning, sales and distribution, and also supply chain management. And in the end, every system line is linked to our factory. So mission critical workloads, if an SAP is down, production is down, also in our cases, and not good if it's down. So this is why we consider it really as a mission critical workload. That's why what this project made also a small game changer for us, because back in time we also had some glitches in the infrastructure, and we knew that with AWS it might improve. If we were successful, we'll find out in the next couple of minutes. So that's also the reasoning why did we even consider the move to the cloud. So within Siemens, we have sometimes reorganizations, and reorganizations don't really care about the system landscape you have. And we had back in time the topic that we had 2 big SAP installations which we needed to split. We didn't want to really invest anymore in on-prem technology. So we already had experience in the cloud since 6-7 years. So we knew also how workloads work in the cloud. We were not really sure about having an SAP in the cloud, but we said back in time, okay, let's try it out. Most probably it will make sense. And we started some kind of POCing, some discussions with our central IT friends, with friends from AWS, to see if that really works. Benefits, I think the typical ones, providing flexibility and scalability. Okay, SAP is not really, you cannot really scale only to a certain extent, but it's not a cloud native topic. So, but nevertheless, we had also some gains on scalability afterwards. And with move to the cloud, I think it's clear for everybody that the future is not on-prem anymore, but in the cloud. And this we also took as a starting point to prepare our landscape, also our monolithic old landscape, for the future. And of course, financials always count, sometimes even more. Promising business case. After first analysis, really high-level analysis back in time, we also thought it might be achievable. Normally, we calculate a positive business case when it pays back in 3 years. And this was in the initial analysis valid, so we continued. And what was our way to the cloud? How did we approach it? So from the very beginning, the selection of a cloud provider was the first point. Obviously, we have chosen AWS, otherwise I would speak somewhere else today. So that was the first thing. As mentioned, we had already some expertise how to do things on the cloud. We knew also about the reliability of AWS infrastructure services. That's why we said, okay, check mark on the cloud provider itself. Doesn't mean that everything was decided, especially not on financial stuff and so on, but at least it was clear in which technology we will go. Because we also had a better feeling, we know at least how it could look like. That also was very important for the discussions then with our implementation partner, that we at least had a kind of understanding how it should look like in future, and that led also to better discussions. Then the next part was selection of implementation partner. We didn't want to do it alone, and we also did not have the capacity to do it alone. So we went in a typical RFP phase, 4 to 5 providers. When we had all this together, we built it out a detailed business case, for the overall program, but also per system line, because every system line owner is very cautious about the costs. So we needed to convince everybody that the business case is really there. So that took some time. And as in, I think every company, and the bigger the company is, perhaps the regulations are even more intense. We had also a long discussion in regards of how do we apply all our internal cybersecurity rules, which of course had also the impact on the network and the infrastructure architecture in regards of how do we design the network and so on. And Bima will explain later on how we did that. And one also critical success factor was the connectivity, because back in time, all our SAP systems were in the intranet, where we had them since 15, 20 years, so nobody really took care about activity topics because everything was transparent in the intranet. We have chosen a Direct Connect and we improved it a little bit internally. We call it now Direct Connect Plus. That means that we also established within the Direct Connect an IPsec encryption in order to be really sure that our data are also protected. And after all that analysis and design work, we started to define also the migration approach. Coming to challenges we had, believe it or not, but we also had some internal discussions, I would call it, IT internally. So I'm working in the IT department. We had even to had intense talks, discussions with our IT folks, which were used that SAP is on-premise, they knew how to tweak it and so on, and explaining those colleagues, hey, cloud has some advantages. That were good and intense discussions. Didn't expect that, to be honest. But also discussions with the business stakeholders. You could imagine if you talk to a CFO and explaining him moving his business critical workloads to the cloud, where perhaps the control is not as it has been potentially before. That were definitely intense discussions and also some back and forth. But finally we did it. As mentioned earlier, cybersecurity, data privacy, export control, all these regulations we have internally needed to, of course, to be fulfilled. Therefore, we included also our colleagues from cybersecurity from day one in order to avoid later on certain issues or pitfalls when doing migrations or when defining go-lives. Partner selection, always an intense topic within Siemens. So I think it took us several months to really completed the RFP process. If you plan to move, migrate also with a partner, plan enough time, dependent on your network there. And we thought what would have been a huge challenge is the whole topic of connectivity and firewalling, opening ports and so on. Because as mentioned before, our SAP systems were legacy. So 20 years, somebody did some settings, you were not even aware of, people left the company, nobody did anymore why some changes were done. We didn't underestimate it from the very beginning. Also, Vimal explicitly mentioned, hey, really invest time to do the analysis to which systems your SAP is communicating, establish connections, and so on and so on. And the time paid really out, we invested there in the beginning. That's why we had later on pretty smooth go-lives. Why AWS? Just recapping a little bit what I outlined before. We already had a long partnership. I think we started 2014 around with AWS, also already starting moving lift and shift to the cloud. We learned a lot. We had extensive cloud experience. What we didn't have was experience how to run and how to architect then for an SAP system. We thought it might be a little bit different. That's why we talked to AWS and asked, can you help us? And they proposed AWS Professional Services, which was definitely one success criteria for the whole project, not only in the design phase, but also later on, at least during the first 1 or 2 go-lives. They help us definitely to avoid some pitfalls. I think we had one glitch in the first migration where we thought, why does it take so long? It cannot take so long. And with their expertise, we speeded it up pretty fast. Finally, we also got the information, or we had work with AWS on a positive business case. They also helped there. Pretty much reliable infrastructure, I think we all know. Since we moved, we didn't have even one outage. And now we are since 3 years with our SAP systems in the cloud. So I think that speaks for itself. And even if it wasn't on the original goal list, support of sustainability goals right now, it's, I think, important for everybody. But for us, also coming from managing buildings and so on, sustainability is anyhow on our DNA. And also selling it to our customers to help them to make more sustainable business. So that was, I would say, a nice add-on. Some word about involved parties. I already talked a little bit about AWS Professional Services. which was definitely worth the investment of the consultant there. As I had the experience how to architect and also later on how to migrate things, they supported heavily in the architecture design, in the automation of tasks, in the migration planning, also deployment, and later on also testing. We, as Siemens internally, had more the task to do all the internal coordination stuff, talking to cybersecurity, talking to our colleagues from central IT, establishing all the firewall settings, ongoing discussions with the networking teams, and as in every SAP project, the business needed to conduct the tests, so we did all the planning and the go-live planning, as you know, from typical SAP project. And of course, not to underestimate the work from the implementation partner, which was in the end responsible for executing, doing the whole stuff, doing everything, infrastructure as a code. That is, for us anyhow, always a given. I don't want to have anybody clicking on the console and test looks different than prod. Not a good idea. They performed some migrations, and it was also very clear from the beginning that afterwards, after the project, they will support the whole infrastructure. They do the monitoring, patching, performance improvement, and so on. Some word on the project organization, and you might be surprised that it's not a typical hierarchical project organization, because two things we did differently. So of course we had our steering board with CAO and CFOs from the businesses. Of course we had some program management where I, for example, was involved. But two crucial topics was in the area of project management that we had always representatives from SAP, from AWS, and from the implementation partner in the decision boards. Because that gave everybody confidence that we're on the right way. We never had finger pointing in between the parties. And the other thing was that we really had a bottom-up decision matrix. So we never said top down, you have to do it like this, and this, and you have to go live then and then. But what we did, we had of course our program lead, but the responsibility for each system line, we handed over to the system line owner. Because it's always easier if you have the affected person also included in the project, and he was responsible then to plan the whole stuff. Of course, not the infrastructure architecture things, but really to deal also with the business, align on go-live state, explain why it's a good idea to move to the cloud and so on. And this also helped us to, let's say, go a little bit over the resistance, the potential resistance we faced in the very beginning. So this was definitely good. And also, what's also very important not to miss, include a financial person from the very beginning, because we know AWS is really great on the infrastructure. On the commercial side, it might sometimes be a bit tricky, dependent also on how you organize your AWS account structure with perhaps central payer accounts and so on. So that's, I come to that later, also on the key learnings. So from the timeline perspective, we moved 6 system lines within 20 months. Also, 6 system lines, what does it mean? So we talk about 16,000 users overall, so around about 20% of our employees working also on the SAP systems. We spent a little bit more time for the first system. We choose our demand planning system as the first pilot to move, because on the first system, of course, we had to include all the activities with the provider, with the operation provider selection or implementation partner. We had to select, also define the migration approach and so on, so that took a little bit longer from the beginning, but then it was, at least after the second migration, it was really kind of factory approach. On the first 2 go-lives, we were already a little bit excited and curious, will it work, will it not work? But then after go-live 2, it was daily business, so also from the program organization, it was really just executed on the bottom level without involving, let's say, the management, and so on. It was just execution. And handing now over to Vimal for more details on the architecture, on the design. So for the techies in the room, that might be more interesting, and also how we define the migration approach.
Now we'll look at some of the key elements of the architecture design process, and then the migration approach we took, which enabled Siemens to achieve the acceleration they were looking for, migrating the entire SAP landscape, including 6 system lines, like Mark said. So first of all, We wanted to get the architecture design right for the first time, which was a key element to provide the required acceleration for this entire migration program, to make sure that we design with the requirements for all the systems in the landscape at the outset, so that we don't have to do any sort of rework or have any challenges and surprises later on. So the SAP systems and the Siemens environment not only had their unique functional requirements for each system line, but in addition to that, those systems also had underlying cybersecurity requirement and the data privacy requirements because of the business processes those systems supported and the data which lived in those systems. So while we were executing this project, although we did not have SAP Lens for AWS well-architected framework in the current shape available then, but what we did was we used the same underlying best practices and principles based on AWS's experience and learning with running a large number of SAP workloads for customers on AWS. And all of those best practices across these 5 pillars were then leveraged to make the correct architectural decisions for designing the architecture for these systems. So first and foremost, for the security. To ensure that we met the data privacy and the security requirements for these SAP workloads, we opted for a multi-account strategy which put systems into different accounts based on their data privacy classification. In addition, like Mark said, we invested time on understanding the different cybersecurity requirement and regulations which these workloads had to adhere to. And then accordingly, we established a secure network connectivity between the on-prem corporate network and AWS environment, which involved deploying an IPsec VPN over the direct connection which was established for this project. In terms of reliability, to meet the availability requirements for these mission-critical systems, we decided to have a multi-AZ redundancy deployed for all of these systems. In addition to that, depending on the requirements of each of those system lines and balance against the cost, we decided to implement automated failover clusters where system recovery objectives required so. And this was closely tied with the cost optimization topic, because instead of having a single architecture pattern for each of the system lines in the scope of this migration program, we tried to understand the business criticality of each of those system lines and have an architecture which aligned with those business requirements and not overdo, leading to unnecessary costs. In terms of performance efficiency, again, these systems were performance critical, so we tried to understand the performance requirement of each of those systems based on their historical workload and utilization data from the on-prem infrastructure, and then try to map that to SAP certified instances for deploying these workloads on AWS, which allowed us to ensure that that immediately after migration, the customer did not run into any performance challenges, which we further streamlined through a right-sizing exercise after we went live. To ensure operational excellence, the use of infrastructure as code was a foundational decision made early into the project after we completed the POC. We decided to use Terraform as the tooling of choice for implementing ISC, because that was the standard used by Siemens for workloads beyond SAP in their environment. This ensured that they were able to leverage their existing know-how and artifacts into this project and not have to start something from scratch with a new tooling. To give you a big picture of the overall landscape which was migrated and what it looked like in the end. So we had 6 different system lines which comprised of approximately 16 terabytes of data in HANA databases across those systems. And then we leverage the latest EC2 instance families available back then to deploy this workload on AWS, ensuring that we get the best price performance outcomes for Siemens. In addition to leveraging the core services for compute and storage for deploying this workload, we also made sure we used all the SAP specific purpose-built services to make sure that we use cloud-native architectures for improving the performance and reducing the cost of operations. So one such example was the use of AWS backend agent for backing up all of the HANA databases, which meant that we did not require any third-party backup management solution or a complex manual multi-step process. Similarly, we made extensive use of AWS backup and Amazon CloudWatch to provide the operational capabilities required for a critical workload like this. So this is an overall architecture. It looks very complex, but I'll just walk you through this architecture and the key components of it so that you understand the thought process we had and what the final result looked like. So in alignment with the SAP lens and the AWS well-architected framework, like I said, the key consideration was security and ensuring that we use a multi-account structure for deploying these workloads. So we had all our non-production workloads running in a separate account than the production workloads. In addition, Siemens also had a requirement of storing their backups in a cross-account format, which meant that any loss of account, it still not impact the durability of the backups. So we had all our backups stored in a dedicated backup account, replicating the backups from the workload accounts where necessary, and in case of the backend agent, backups getting directly stored in the backup account. In terms of network security, like I mentioned earlier, the connectivity between the Siemens on-prem environment and AWS was established through AWS Direct Connect. But to ensure we met the cybersecurity requirements which Siemens had, this traffic was flowing further on top of an IPsec VPN deployed on this AWS Direct Connection. One other key element, we had in this architecture design, where we did a lot of deliberations and make a final decision, was to deploy each of these SAP systems line in their own subnets. So while we had one non-prod account for all non-production systems and one production account, and each of them having one single VPC, we had separate subnets for each of the system lines, which allowed network level segregation for each of those system lines and able to meet the requirement which Siemens was having in the on-prem world as well. This also further streamlined the implementation of network controls and for the firewall configuration, allowing the traffic between on-prem and the cloud environment. Without the use of this approach, we would have been dealing with several hundred thousand or several thousand firewall rules to be configured to meet the requirement of all the interfaces between SAP and non-SAP systems in the Siemens landscape. Moving on and looking at two specific aspects of this overall architecture where I want to focus on. One is the architecture considerations made for ensuring the high availability and disaster recovery requirements of these workloads were met. So like I said, first of all, we decided to implement a multi-AZ redundancy for this workload, which meant that in case of an AZ failure, we still had an ability to make sure that systems are available for business. But like I said, we did not have a single pattern for each of the systems. We looked at the different availability requirements of the systems. So we had a pattern one, which we called a cost-optimized solution with manual failover. So this is a solution which we implemented where the systems had a requirement to protect against any data loss, but in terms of recovery time, the requirements were not very stringent. We could have the system recovered under 4 hours, and such system lines did not require the use of a relatively more complicated high availability cluster setup. But for the rest of the systems which required a fully automatic failover in case of any failures, we leverage a high availability cluster solution for the HANA database in the same account in the VPC where the rest of the systems were deployed. Now, both of these architecture patterns were completely transparent to the end users because for any failures, we had the ability to route the traffic from the end user to the correct active node without having to change anything on the interface configuration, third-party interfaces, or the end users who are using those systems. Now, beyond the high availability and disaster recovery element of the architecture, another key element was the backup and recovery requirements and the solution we implemented for that. So again, like I said, we decided not to use a third-party backup solution and we favored cloud-native approaches to ensure that we optimize the cost, and we also accelerate the overall migration program because the timelines did not allowed us to accommodate procuring and configuring an entirely new backup solution. So we leveraged AWS backend agent for HANA for performing all HANA database backups. This allowed us to do the backups directly into a dedicated backup account, like I said, without having to deal with a multiple step process, which would then have reduced the durability of the backup solution and the reliability of it. Because now when we take a backup, the backup is instantly durability stored in an S3 bucket without having to be manually moved from one location to other and reducing that management overhead. Now moving on to migration approach. So again, like for architecture design elements for migration approach, we decided to align first on the key approach or the key elements, and those in consideration with the business requirement for Siemens was one, to minimize disruption to business during the course of the migration, and second, to allow them to do a lift and shift of majority of their configuration from the source environment to AWS, which meant that the overall migration complexity was reduced and Siemens did not have to refactor each of the several thousand interfaces they had between these SAP systems and the other non-SAP systems which were still supposed to remain in the on-prem environment. So we started with a POC deployment, then moved on to define the architecture and the runbooks for performing this migrations. We decided to use a consistent migration methodology across all the systems, which was based on HANA system replication, which allowed us to minimize the complexity and reduce the overall downtime for the business. Use of HANA system replication also enabled one key element of this migration approach, where some of the Siemens application owners requested to have a test environment available even before their non-prod environments were migrated, because for some of the project teams, even the non-prod systems were equally critical like production. So what we did was we leveraged our infrastructure as cloud to provision the SAP systems on AWS well ahead in advance of the planned migration cutover, several months in advance. And then what we did was we established a HANA system replication and the replication of the file system from on-prem to AWS in a completely isolated environment, which then allowed the team to perform very controlled integration tests in that clone environment without affecting the existing BAU environment. And once all of those interfaces and changes were identified and the team was comfortable, then we moved on to repeat the same process essentially for migrating the dev, QA, and production systems. And because of the use of HANA system replication, we did not have to do any rebuild. We simply were able to use the same environment which was operationally tested for doing the final migration. One more key element of this migration approach was the fact that we were able to do operational acceptance testing for each of these systems prior to the go live. So we build the environments, do a test data migration, configure our backup monitoring and high availability cluster solution, which went through an extensive test cycle so that we can validate each of those element of the operational aspect of the system before performing the actual migration cutover. I can now hand over to Mark to run you through the key business and technical benefits which Siemens was able to achieve out of this migration.
Thanks, Vima.
Thank you.
So what are the outcomes from the project? So our CFO and our system owners were happy. We achieved our business case that was also with support or with use of the Migration Acceleration Program from AWS that contributed heavily to the successful business case. What did we achieve, or did we achieve the targets we initially thought about? So did we gain agility, flexibility, and scalability? Yes, even as mentioned before, SAP is more a monolithic application, but we had 2 or 3 occasions where we were happy that we were in the cloud in regards of database adjustments that really helped. What took longer before on-premise was there pretty fast achievable. What we saw in regards of performance increase, because that's also perception, if you move workloads to the cloud, everything should be faster. We didn't see a huge performance increase for dialogue times, but to be honest, they were already pretty good on the on-prem system. But what we achieved or saw also in the very beginnings and when we migrated the first big systems, that we achieved a performance improvement around 20% for long-running background processes. So that helps also, of course, not for the dialogue user, but if things are faster done also in the background, that helps definitely. So you can being able more to have more batch processes. Also, what was not so good for the business case was improved high-ability and disaster recovery, which we included for several systems which didn't have the same high availability before. But it's not always about money, right? So it's also good to have alternative solution when, in the case something happens. Luckily, we never used it so far, but at least it's technically there. And also, that was one big concern in the very beginning. We don't want to have any interruptions of the factories, of the production business, of the supply chain. Even with the first go live of our demand planning system, we had, of course, smaller glitches. Perhaps one system from an external partner was not properly connected due to missing knowledge about firewalls and so on. But also the connectivity to the intranet, that was never an issue. So that was pretty good, pretty successful, and everybody was pretty happy about each and every single go live. Key learnings, of course, speaking at AWS, also giving some kudos to the AWS professional services, which was really crucial for the success during go live, but also during architecture setup. So I think you saved us quite some times and quite some headaches. Also, if you consider moving to the cloud, I mentioned it before, involve your stakeholders, internal, also from the business, from cybersecurity. you cannot start early enough with that if you want to have a smooth program afterwards. In our case, but that might also be dependent on your organization, a centralized program, but decentralized project execution and project organization decentralized, that helped really to have also a business buy-in and make the affected people also responsible. Number 4, proper go live planning. I think everybody who's had an SAP project go live knows exactly what I'm talking about. Try to find good slots where you can do the cutover. Do performance testing early enough, functionality testing, interface testing, and be prepared for the what if something happens. It was a learning from the first go live where we saw some glitches in the area of network. For the second go live, we really brought all the network expert in the beginning together when we did the migration in order to be able to detect network issues fast. Focus on automation and interfaces goes a little bit along together. Know your interfaces, know your systems, know your surroundings. To which systems is your SAP system talking? If you have documented everything, good. But we all know if you have a 20-year-old system, it's not everything documented. Involved business administration, as mentioned, that was the only kind of negative thing. It's not so easy to deal with credits from the migration acceleration program because you do not really apply them to your live systems but to other systems. But that also might be dependent on the structure of your accounts. If you only have, let's say, a small number of accounts, it's easy. If you're running 700, 800 accounts, it might get a little bit trickier. And also what we did is after 2 years, we had a well-architected review, which was pretty good because we didn't found too many things. So it looks like we did the right architecture from the beginning. Of course, after two or 3 years, things change on AWS side. So typical things like moving from GP2 to GP3 in the area of EBS, you should do that. That gives you more performance and also a better cost position. Today we wouldn't do the cross-account backup anymore, but now there's also other solutions from AWS with AWS backup for S/4HANA solutions. Now we're moving away from the cross-account and going directly to the AWS backup solution that also will save a nice portion of cost for us in the future and other things. We decided also in the beginning for AWS saving plans with an upfront commitment. Also then, after they're running out or before they're running out, reconsider your architecture, reconsider all the instance types you're using, and then adjust the new savings plans. Also, together with that, have a review on your backup retention times. So I think we were pretty careful what to do there in the beginning, and now we might adjust the retention times a little bit. And also, as it's now available using SAP Lens, as Vimal mentioned, it's a kind of collection of customer experiences which AWS collects, especially for SAP workloads, and apply them. That's definitely a recommendation. Then just one last 2 slides from my side before handing back over to Vimal. Of course, we embedded, and this is one nice side effect, if you run already data lake solutions on AWS, and if you move your source now from on-prem to AWS, you are also able to use, of course, the AWS tools like SageMaker for analyzing patterns, using lake formation for data lakes, or Glue for data integration. So that was really a nice add-on on our analytics platform that we now really streamlined also our SAP data on AWS. Closing my part with just one statement from our CIO. Just reading it out, this project proved that AWS can handle even the most critical mission workloads and set the foundation for our ERP transformation. So this, I think, gives a brief overview what we did. We had 6 successful go-lives and some others afterwards because we just could migrate also easier workloads then in the AWS area where we have the SAP workloads. We have only positive feedback from the controllers, from the business units and the business sites and business users. So with that, I'm handing back over to Vimal, and he will give you a brief update on latest updates for SAP on AWS. Thank you very much.
Thank you for your insights and your partnership. So before we open for Q&A, I just want to share some recent updates from AWS on innovations for SAP workloads, and also share some resources for you to start your journey for migration and modernization of SAP workloads. And if you're already have started that journey, how can you further accelerate it? So AWS has always been at the forefront of innovation throughout our 15 years history supporting SAP workloads on AWS. And this has helped thousands of customers maximize their investments for SAP workloads on AWS, and more recently, SAP RISE workloads on AWS as well. So it's not just, first of all, AWS's overall cloud leadership. Analysts at ISG have also validated AWS leadership in the SAP space, and AWS has been named the leader on their Provider Lens Quadrant report for 6th consecutive year. And ISG really has called out AWS leadership in a number of areas, including the high performance infrastructure services, automation capabilities, and the way we support accelerating the migration program for customer through AWS professional services for SAP and our partner network. So I just want to share, a snapshot of what's new for SAP on AWS and all the announcements which have been made, recently. So starting on the infrastructure front, AWS has announced general availability of Gen 7 EC2 instances, including R7i, R7a, M7a, M7i, and each of these instances now use 4th generation custom Intel processors and AMD processors, which allow up to 50% price performance benefits over the same instance types from the previous family. On the migration and the operations front, AWS Backup, AWS Migration Hub Orchestrator, AWS CloudWatch Application Insights, AWS Systems Manager, Application Manager, all of these AWS services now effectively support SAP HANA-based deployments, which can help you improve your migrations and make your operations on AWS more efficient for the SAP workloads. On the innovation front, AWS SDK for ABAP has been GA. This allows ABAP developers to very easily integrate and leverage AWS services for improving the business processes. More recently, Amazon Bedrock, which is our managed service for building and scaling generative AI-based applications, has also been made available through AWS SDK for ABAP. We also have had AWS supply chain solution now generally available, which supports integration with SAP S4HANA and ERP-based solutions. So yeah, just that you are here at reInvent, I'll also like you to invite and make a point to the other SAP sessions we have at reInvent. I can pause here for a moment. You can take a picture, or you can refer to the reInvent app to look for all the SAP related sessions, and do verify the location and the time of each of these sessions. So please do join us and look at why the industry leaders are using AWS RISE for SAP, and how they are using AWS data lakes and RISE with SAP to transform the business processes. You will have other customers sharing their insights. Similarly, if you're looking for a more technical understanding on your innovation options, you can look at AWS services, RISE with SAP and BTP to innovate faster, and our session on AWS SDK, which will give you a more interactive understanding of what are the options available for you to improve your SAP workloads. And lastly, you can always reach out to us, throughout the reInvent, the AWS SAP team. But you can also reach out to the AWS on SAP on AWS experts for complimentary, discussions to understand your situation and help you get accelerated on your SAP migration and modernization journey.